All right, so welcome to my presentation for the project that I did, which is image processing with LabVIEW. Now, I wanted to design a program that had some basic functions in order to process images. Two very useful things in image processing is to reduce overly bright sections, the highlights, and to brighten up shadows and very, very dark sections a little bit. The next thing that I wanted to do was have a button that kind of did those for you with preset parameters instead of user control. This is usually used in kind of quick editing applications where you want to turn something around relatively quickly. What's nice is that it's preset, so no adjustment required. Less fine detail, but pretty useful. Another thing was to adjust the balance of colors in the image. Another thing is very useful is to be able to adjust those to really bring out the kind of hues and character of the image that you're looking for. So with any program that's editing a file, you should be able to open the the file as well as save it. So those were important. Also, for different images of different sizes, it's nice to be able to really see the full image that you're working with. So without having to modify the canvas. So what was done was a zoom function was added. And lastly, there kind of needs to be a live preview of what's going on. It's one thing to be able to manipulate all of these different, these different features, but if you can't see what you're doing as you're doing it, that's not very helpful. So the real-time image preview generation was important. So, and that's all generally for the front panel of the user interface. Now, the build theory and strategies that went into building the block diagram were relatively simple concepts, such as the main mechanism to run this program was the unbundling of image data into the individual red, green, and blue channel values for each pixel. So with that, the values could be selected for a specific range. So the very bright ones up in the high 200s could be reduced, and then the very low values in each of those channel data is somewhere, I think I chose below 100 or maybe 80, I forget, was very important to be able to manipulate. So after that, the idea of using Boolean arrays, which are basically arrays of ones and zeros, true or false, was used in order to be able to isolate those values that were over a specific threshold, because basically it was giving me a feedback array of, is this pixel data above a certain threshold? And if so, it was used to be able to manipulate those values through the whole array. So what I could do is use scalar functions, scalar multiples, in order to manipulate all of the data at the same time, as opposed to running for loops for the data manipulation as well. The for loops was used to isolate those data and search for those data above a specific or below a specific value in the first place, but not overly use for loops to speed up the program's efficiency. Also, the program worked in a kind of sequential hierarchy format where the most impactful adjustments came first, and then the least impactful came last. So the highlights and shadows sliders were the most impactful generally on the image quality. And so those were first, then next the balance button, because what happens is that the edits from the sliders is preserved, and then you can select the balance on top of that. And then lastly was the hue sliders, which just were basically a 0 to 100 percentage multiple of the final output color channel value. Now, some of the build difficulties that I encountered is that, well, believe it or not, addition and subtraction works on zeros too. And although simple and straightforward and something that is obvious to know, when you are trying to remove a small subset of values from data, it was something that seemed like a good idea at the time, but it didn't end up working out. So instead, the solution was that multipliers and percentages were used instead, because 0 times anything is still 0, which allowed me to work on only the desired values. Another issue encountered was the logical flow of what I thought was going on and what I was doing in the program didn't quite work out, and I found that the converters and the data type representation was very important, and something that I had to pay a lot of attention to. Another one is that the for loop original design I was trying to only do with one, but what it meant is that I could not isolate only highlights and only shadows, but that the mid value data would be changed as well. So I ended up having to split the for loops. Not all images are the same dimensions. How do I make sure the data is not left out? Well, what I did was I used the array size function wired to the for loop iterator. So no matter what size the image is in pixels, the loop would always catch all of the data. Let's see, the images didn't fit to the canvas. So yeah, so what I had to do is there was a property node for the image display, which I ended up finding did that function relatively well, and it zoomed in the image or zoomed out in order to be able to fit to the canvas. Oh yeah, in building the initial for loops, the automatic system when you do the comparisons was putting the for loop with a shift register in and out, which did not work at all. So what I ended up doing was changing it to tunneling, which gave the desired output. Yeah, and then the another thing too was the real-time image preview. So I put the whole program into a while loop, which worked, except for it made the open file function repeat continuously too, and crashed my computer. So needed to put that open and save file function outside of the while loop. Made things run a little bit nicer. Oh yeah, another one is that when I was rebundling the data, it wasn't coming out as image data. It was still coming out as just an array data. And what I realized is that there was actually an input on the top of the rebundle function where you could input the type of data, so it knew what it was that it was looking at. Essentially, it was getting a bunch of values, and it's just a bunch of values. But whereas when I wired the image colored data output into the top input, it knew that what it was looking at was image colored data, and it didn't take the initial value. It took the values from the array that I was outputting, and but it knew what it was looking for, which was important. Oh yeah, I couldn't find any JPEG functions for the longest time. Did a bunch of internet searching, and eventually I found out that there was other functions palettes hidden that were not auto-pinned because they're not as common. But if you search for them in the function palette, you can add them to your function palette, which was a simple solution that took me a long time to figure out. But it ended up giving all of the different image manipulation general blocks that I needed, like file opening and writing. And then the last one was a little bit more minor, which is there was heavy color banding and distortion when I was doing the initial values, which I thought were going to work well. So what I ended up doing is just reducing the range of editable values. So the adjustments weren't quite so severe, and that helped normalize the image in the final outputs. So a couple other things that I used while I was building in development. There are some functions that really helped with debugging and really verifying the program was working up to that point as expected, like the diagram disable structure. hugely useful because at a number of points I knew what I wanted to do at the end, and I already had a relatively working thing, but I wanted to make sure that the previous steps were working, so that allowed me to do that. Another one is impermanent indicators. This little array indicator was just the savior of the program build because it allowed me to verify that the numerical functions were working as I expected them to. Another great one too was these little blocks here. They're called reshape array, and what it did is it took the one-dimensional color channel array, so like let's just say green here, and it recut them into the original dimension and turned it into a 2D array. And it allowed me to view the intensity of those different pixel values. So if I, let's say, just reduced the highlights, it would actually darken the very bright areas on this little screen. So it showed what I was wanting to do, but it didn't have to compile all back into the same image. So I could check that the image was working as expected as I went. And this is the main program block diagram. Looks a little convoluted at first, but the flow is relatively straightforward. So outside the while loop, the JPEG opens. You get to select which one. It enters the while loop, and then all of the editing happens. So this is the property node for the zoom, so you could fit the image to the size of the canvas, the workspace. The data comes in, and the image data is then the image color data. That's this image is unbundled. It's run through a decimator. So what basically the red, blue, green channel data came pixel by pixel. So it would be pixel 1 RGB, pixel 2 RGB, pixel 3 RGB. So what this did is it took the first data, the red data, and put all of those, so basically the first of every 3 values into its own channel. Same thing, second of every 3 into the green channel, and third of every 3 into the blue channel. And then all of the edits would happen channel by channel. This block here is the highlights, so anything above 155 got edited. Anything less than just continued out as the midtones. This is the shadows, so similar thing. Anything less than 100 had edits happen to it over here. Anything greater than continued out as midtones. The midtones were basically just the overlapping values of ones and zeros, or ones and ones. All the ones from the highlights, all the ones from the shadows that were overlapping, so that gave the midtones multiplied by the original. 1 times the original data is the original data. These are the percentage manipulations for the highlights, percentage manipulations for the shadows, which are controlled by the sliders on the front panel by the user. So that would do a percentage reduction for the highlights and a percentage increase for the shadows. Because each of the highlights, shadows, and midtones data was separate without any overlapping values, they were all just added together to form the output array of the adjusted values. Same concept was used here for the balance button. However, instead of user-controlled sliders, they were given set values. I found that these values performed the appropriate amount of adjustment. And again, highlights were isolated, shadows were isolated, and midtones were isolated, and because none of them had overlapping values, they were all able to be added together without problem to the final output array. Then that array, because this whole thing is a red channel, had a 0 to 100 multiplier, percentage multiplier. So basically, the output array had the adjusted values, and then you could take all of those values from 100% down to 0%. So if you took them down to 0%, well, the red channel would go away. 100% the red channel was there. And that was repeated for all 3 channels. So now that all of those edits had been done on the data, the next thing that needed to happen was for them to be re-put in the red, green, blue first pixel, red, green, blue second pixel, red, green, blue third pixel order, which I found this cool block called the interleave function. Now that the one-dimensional super long string array of all the pixel data was back together, it could be rebundled, through the rebundle by name function, which took the same, which is basically this little section here is the inverse of this section here. So the color data was split into its image. The image data was split into colors, split into their individual channels, edits done, re-put into general color data. It was told that it's image color data, and then it could be output by this draw image onto the preview screen. So because this is all in a while loop, it was able to be real-time live edits, everything displayed as it went. And then a clever little solution I had was that I used what is labeled on the front panel as a save button as the terminator for the while loop. So as soon as you press that, what is labeled as a save button, it terminates the while loop and the data passes out into the write JPEG function. And after you save the file, the program is finished. So next slide is just a demo, but we're going to do a live walkthrough demo. So this is the front panel of the project. Let's run it. So prompts selection of a file. Let's just, we can do this. These are a few of my photos from my photography days. And you see it's not quite the right size of the canvas, so let's just try 1.5 ratio. No, that's a little too big, so you can step that down. Looks like 1.2 is just about right. So that's the zoom function. Balance function, it automatically reduces the highlights up here in this region and the shadows in the dark region. Highlights slider does something similar. You can see it kind of walking and stepping up and down. Very bright, not so bright. And then same thing for the shadows, but instead of making them darker, it actually reduces the shadows. So very dark shadows, less dark shadows. And then also you can mess with the color saturation. So here, there is, no longer any red in the image, or essentially no longer any red in the image. And that allows for all kinds of different manipulations of the hue, so you can really get the image to look kind of how you want it, which, let's just say for this one, we want a little bit more bluish and a little bit more dark blue. So, and then you can balance it out, and let's just say, you can also adjust even a little bit more. So let's say we're really looking for something a little bit flatter and a little bit bluer. So now the original image is much flatter and much bluer. Click the save button, and let's just say test 1. Enter, and the program is finished. And now you can see we have the original image and we have the edited image. Noticeably different, simple function. We can run the program again just for another very, very quick demo to really show the functionality. Let's do a quick one this time. So, and let's just say we want this one really like kind of tan and yellowy. So we can bring it down. Right. And maybe just mid-level flat. No, that's a little too flat. So what we're going to do is we're just going to bring it up. Maybe the dark shadows can stay. We like the dark shadows, but the brights are a little too bright. And so, we can move these how we want them. It adjusts in real time. We can do crazy stuff too if we want to. Not as useful, but it's available. And then again, save, terminates the loop, and we can save it as whatever we'd like. And again, we can see the original image and the new image are different, and it saves, and everything is good to go. The user face is very easy to use, very intuitive. It's very bright, very low, it's clearly labeled, simple. So the program was a success, and it allowed quick editing functions for photos. So I had a fun time with this project. A little bit tedious sometimes with the scalar functions. That took a little bit of fleshing out for their algorithms, but overall I had a pretty good time building this project, and hope to keep using LabVIEW, as I found the flow programming style just really fun to work with, and a little bit more my style as a artist and photographer. So hope you guys enjoyed it, and thanks so much.